Friday, Friday, gotta get down on Friday. Looking forward to the weekend. Yeah, Friday, Friday. Hey, you guys, looking forward to the weekend? It's Friday. You know how I know that? I heard the song. And it's also, let's see, we're up to number 5 on the top 10 countdown. Number 10 was Body Systems. Number 9, Brains. Number 8, Polymers. Number 7, Osmosis. Number 6, yesterday, Worms. And today, number 5, right after this commercial break. All right. Hey now. Mr. Kovacs class. It's Mr. Kovacs class. You might learn a ton. It's Mr. Kovacs class.
It's interesting too.
It's Mr. Kovacs class.
And he's super cool.
It's Mr. Kovacs class. That's right, you know him, you love him. Number 5 on the countdown list is our favorite chemicals that speed up reactions. We know them as enzymes, and we've studied so many enzymes and things like amylase and catalase and pepsin and trypsin and lactase, and so many enzymes that we've studied. Let's look back at enzymes that we studied this year. What do we know about enzymes? They speed up chemical reactions, right? All these chemical reactions that would take place anyway, but enzymes speed them up. They're catalysts. Why are they important for life on Earth? Because most of the reactions that happen that keep life alive, living things alive, happen too slowly to keep them alive. So they need enzymes to speed them up so that life can actually occur. Enzymes. We learned that the enzyme is not changed during a reaction, right? The enzyme stays the same, and enzymes can be reused after reactions, right? The thing the enzyme is working on is called the substrate. Where they bind together is called the active site, right? That forms the enzyme substrate complex. And then either hydrolysis or dehydration synthesis happens and you get a product. Which one of those things happened in this example? Hydrolysis happened because it broke apart, right? Hydrolysis breaks apart, right? Using water. This enzyme is a hydrolytic enzyme, right? Enzymes. So you should know that, right? The big blue egg is the thing it works on. The pink thing is the place where the work happens is called the, very good. We learned that enzymes are specific. It all has to do with the shape. They have to fit this active site. Enzymes. When enzymes change their shape, right? We studied 2 things that can make them change their shape. One was high temperatures and cause them to denature or change their shape. The other was high or low pHs, very acid environments. And we tested those in lab with a bunch of different labs. We used catalase, we used amylase. Right? And we call when a protein gets bent out of shape, we call it denaturing, denatured protein, right? Extreme environments can denature proteins, can break them up into pieces, make them not work right. Of course, there are enzymes all over in every cell, but some of our favorite enzymes we found are in the digestive system, right? Like pepsin is that stomach enzyme that breaks up protein into smaller amino acids, right? Or in the first foot of the small intestine, the duodenum, there's all kinds of protease, lipase, lactase, all kinds of things in there. Sucrase, lots of different enzymes. Most of them are made by the pancreas. And of course, we did a lab where we studied the salivary enzyme of amylase. Amylase, remember, what does amylase break up? That's right, it breaks up carbohydrates into simple sugars. It breaks up polysaccharides into monosaccharides. Enzymes are like superheroes, right? They either put things together or break things, and they can be reused. And and of course, my favorite enzyme superhero is, that's right, Pepsin Man. Pepsin Man. That's it for a Friday Bellringer. Of course, after this Bellringer, there's an Ed puzzle about enzymes, a review, right? Amoeba Sisters. And then, of course, we're finishing up games today. Your game should be built by the end of the period today so that they're ready to be played on Monday. So when Monday comes in, I want them to be play ready. Okay? So that's what your task is today. Whether you have 1 period to do it or 2, it's the same. All right. let's get to it.